A number sequence is an ordered list of numbers defined by a rule. Each number is called a member or a term. If the sequence continues forever, it's known as an infinite sequence, so often you'll see these dots at the end. If it ends at some point, it's known as a finite sequence. Lovely. Right, general or nth term. You should have heard this phrase before. This is the general rule of how a sequence is formed. It's usually given in algebraic form, using the letter n to represent the term number. So, you will see this un. Okay, that's how we show that it's the nth term. Okay, so un represents the nth term, and then this is my rule. If I wanted to show that I was finding my first term, I would show that it's u1. Okay, so u represents the term number, or it expresses the fact that it is a term, and the 1 obviously represents the first term. So what I would do is I would replace all of my n's with the number 1 and come up with the value of 3. So the first term was 2 multiplied by 1 plus 1. As you can see, I have replaced this n with the number 1. What do we think we're going to do when we're finding the second term? We're going to replace it with a 2. So it's 2 lots of 2 this time. What's 2 multiplied by 2 plus 1? 5. And u3 would be 2 multiplied by 3 plus 1, which is... Normally, once you've got a few of them, especially if you are on the wall, and you notice that this would give you a linear sequence. Okay, what do I mean by linear sequence? How do I know this would be a linear sequence? Yes. How would I know from the formula that it would give me a linear sequence? Not necessarily the first number. It's the fact that it's just an n. There's no n squared or anything fancy on there. Okay? Do you remember why it was mx plus c? Yeah. Vaguely. Okay, it's kind of similar thing. You've got mx plus c. Obviously your x is your n this time. Okay, so it will be linear because you've just got n there. So it would be the sequence 3, 5, 7. I'm going to show it to keep going. By showing it's got dots on. We could do the 4, 5, 6. Doesn't matter. But there we go. Yeah, happy with that? Yeah. Nice, easy start. 3 multiplied by 2 to the n. Is this going to be a linear one? No. No. Okay, we've got fancy stuff happening here. But the way we worked out these ones is going to be the same thing. So u1 is going to be 3 multiplied by 2 to the power of 1. What's the answer to that? 0. U2 would be, what would I write here?
3 times 2 to the power of 2.
What is that?
2 times 2 is 4 times.
Oh, you know, you're right. I kind of wanted someone to say 36. Was anyone tempted to say 36? 3 times 2 and then square it? No. You're horses. You mean brackets, third mass, fourth mass. Oh, I'm learning need to be here. Next one. 3 multiplied. We're trying to use the word multiply though rather than times. 2 to the power 3. Oh, here we go. What's 2 to the power 3? Times 3 is 20. What's happening to these numbers?
They are being
Okay, so I could be fancy and know that it would be 6, 12, 24, and the next one 48. Nice.
You're wrong.
You got it, so.
Good.
Okay, do we know what that kind of sequence is called?
Geometric.
Yes. Yeah, nice. So this one here is secretly linear, but we would also call it an arithmetic sequence. And this one here is a geometric sequence. Just as a side note. I need to keep an eye on the time, so when that gets to like 8, 9, I have to stop it, otherwise it won't save it. Okay, so just keep an eye. Right, arithmetic sequences. I know you say arithmetic, but for some reason we call it arithmetic. We just say it in a different way. Don't know why. It's weird. But this is an arithmetic sequence. So an arithmetic sequence is a sequence in which each term differs from the previous one by the same number. The number that it's different by is called the common difference. Handy? Okay, so the difference between them is called the common difference. It's represented by the letter D. Again, handy, you remember that D stands for difference. Here's 2 examples of them. What is my difference of these? Okay, so my difference is 3. You'll notice that there has to be the same difference with all of them. And this one. Be careful. So your difference can be negative.
So you would write it as a negative?
Yes. Okay, so we've got a difference of 3, difference of -4. Now we need to establish what the general formula is going to be. So we know that the first term we always describe that as U1. That was wrong just now, yes? So when we're talking about terms, we always call them U something, and the first term would always be U1. We know that the common difference would be D. So that means that if term 1 was U1, then term 2 must be U1 plus D, yes? Term 3 would be U1 plus 2 lots of D. And U4 would be U1 plus 3 lots of D. Yeah? What I want you to do now is to start connecting this number here with anything here. Or what kind of pattern can I write for UN? So I want to write it for any term number. Well, what do we see in each of these? U1. Okay, so our rule is probably going to be involving U1, just because of the way I wrote it. Plus, now how am I going to describe this? ND. Now think about it, is it ND? Because in this one, N was 2. Do I have 2D here?
Yeah.
So you're close, but not quite.
Oh.
What is the connection? What secret number do we have here?
1.
So here this was N was 2 and that's 1. Here this was 3 and that was 2. So it's 1. Nice. Okay? So that is the rule for the general formula for any term number in any arithmetic sequence. Okay? I'm now going to get you to grab your formula booklets because you have them handy because you only just consider them. And we're going to try and find the section that looks at sequences, and you're going to see that you get given this. You don't need to learn it.